Hello everyone. I hope you're all doing great. I'm very happy that we are all together here on our first real-life engineering meetup. And I thought that it will be a great idea to start with something more general, something interesting and something basic, but also interesting. And we will take a look how web applications work and why sharks don't want you to use internet. Like, okay, maybe you have some ideas. Somebody have any ideas why sharks are involved?
Because they cannot do it.
Because they cannot do it, of course, and they want to use it. Good. Yeah, I like your idea. So, but first of all, how we access web applications. How we access a web application, for example, OANDA.com. We use browsers. So browsers is our gateway for the web applications, right? And the browser is an application that actually you provide him an address, OANDA.com, and it goes to the server, takes your files, and run it for you. But again, it goes to the server. What is a server? Server is actually a computer, big computer that runs any type of applications. For example, some databases, AI models, like everything, right? APIs. And okay, so now we have our browser. We want to go to OANDA.com. We're searching OANDA.com, and we want to get to the server where OANDA applications is working. But wait a second. Our browser and like overall servers do not have names like OANDA.com or something like that. They understand numbers. They understand IP addresses. So we need to get an IP address for the server. How can we do that? We have one thing. It's called DNS server. DNS server is like a phone book. So you go to it, ask you that, please give me IP address for the OANDA.com. And under the hood, what it's actually do, we will not go deep into it. It's like your DNS is a guy who knows a guy who knows a guy, and this guy goes to the guy who actually knows a guy who knows your IP address. Because it's a big network, how to find it. And then DNS server actually respond to you with the IP address. And usually it happens like in milliseconds. We don't even realize that. Of course, your browser, your device, and your DNS server have the memory. And if you already accessed OANDA.com before, it won't go to all these guys and ask for the IP address, because he remembered that you accessed already the OANDA.com, right? And it's called stub resolver. So, okay, now we have IP address for OANDA.com. It's literally IP address for OANDA.com. You can try in your browsers right now. It will also work. And what happens? Your browser goes to the server. The server, for example, if it's running service for something like Nginx that is serving static files, it will return HTTP, CSS, JavaScript, images, all static files. And then your browser will run them. So like your browser is like a pen that is cooking all these files. And yeah, a little bit history. First browser that was called the World Wide Web was created in 1989. And it looks like this, right? So it's the first UI to search the internet. And if I'm not messing, yeah, there was no images there, no support for images, because first browser with image support, it was Mosaic in 1993, yeah? So, yeah. But wait a second. Before our browser, first browser came out, we have an official birthday of the internet. So the internet that we call right now, it was created in 1983. So, okay, it's like 7 years before the 6 years, 7 years, 6 years before the first browser became. But before that, at 1969, there was already a first message sent through the network, some network. And this network was called ARPANET. ARPANET is like the first instance of something that we call internet. It was a web of big computers. Back then, when computers was like a half of this wall, they were connected to each other and passing that data between them. And the first history of the first message, it was sent on at October 29 at 10:30, and the message needed to be one computer. It was in Florida, right? In Florida, two big computers were exchanging the message, and the message that was one computer sending to the other was login, like just basic string, login. But something goes. Of course, it's like a demo process. Nothing works when you show it to somebody. Only LO was sent. Like the rest of the word, login, like gin, wasn't sent. And so in the history, the first message that was sent by in some kind of network was LO. So again, our web browser was created at 1989. How users were using like internet before? They used CLIs, right? So you used your command console to access your internet and view some files, right? You just view through the files, through the text, so nothing such as videos, images, or something like that, right? So again, back to our browser that is cooking our files. Our browser is now running HTML, CSS, images, JavaScript, and it's fine. Like it's called front-end only web application. For example, it's a good example of front-end web applications are password generator or GVT.io. Yes, it's like your application don't communicate with some other outer world, or it's just running in your browser. But let's take a step further. What if our John Doe want to send a message to Don Joe? We cannot do it using only static files. So what we will do? What we need to send a message, for example, between two users? Any ideas? Yes, we need a backend, so that will provide our communication. And so how will it look like? Our John Doe send a message to the backend server, to server where backend for at least backend API is running, and this API will save your message to the database, and then when like Don Joe will view the messages, he will request to view the messages. The same process, your server will give you back, the request will go to the server, to the API, read from the database, and return to the user, right? And it's fine. The same process goes back forward. And this approach called server-client architecture, it's performed via HTTP requests. It's reliable and stable. But a question, is there any other way of exchanging data, sending messages between these two clients? Do you have any ideas?
Yes.
Yeah.
Peer-to-peer.
Right. Genius. Peer-to-peer. So actually, there's a thing called WebRTC. And actually, it's built in our browsers that our browsers can connect peer-to-peer with each other using WebRTC. And WebRTC is using UDP transferring protocol. It's fast. It sacrifices reliability and stability, yeah, to the speed. And basically, WebRTC is created for exchanging videos, so it's like online calls or something like that. But we can also use it to transfer files, to transfer data, anything. So, how can we perform it? The problem is that not always you can connect to the person like directly. You cannot give your, like you don't know IP address of the different other user because there is something like NAT, VPNs, firewalls that are dynamically changing our IP addresses, right? So we don't know the IP address of our bro that we want to connect with. What should we do? Unfortunately, we need to use servers. We cannot get rid of servers. So, first step? Our client one will create, first of all, it will go to the server that called Stan server. Stan server is actually, they are free. There's a lot of Stan servers from Google. It's basically API that you ask him, and what Stan servers do? They are providing instructions how to connect to you. Because you need to tell other user how to actually connect to you. And this Stan server is actually doing it. When you got an instructions how to connect to you from the Stan server, you're creating an order with some other information about the connection that you want to perform. With type offer. There's two types, offer and answer, right? The requester and the person that will answer. Then this is order. Our second client needs to get this order to connect to you. But how? Still, we don't know how to connect straight to the other client. We will use WebSocket service. So we actually sending our order to the WebSocket service, where other client is also connecting to this WebSocket server and getting your order. After your second client accept, he says, yeah, okay, I want to perform connection with him. What he do? The same process. He goes to the Stan server, getting the instructions, creating an order with type answer, and then passing it back to the WebSocket server. Your first client is getting WebSocket order. And at this moment, when both clients have orders of each other, two orders, at this moment, boom, they can perform a UDP connection. So this is like another way of creating, exchanging data. If we'll compare these two approaches, there's no like the best one. Because in case of peer-to-peer connection, of course, you're getting rid of provider. You can connect straightly, and the speed will be faster. But first of all, both clients need to be online. So in real time, you need to exchange the data. And also, because you're connecting straightly to each other directly, you cannot stay anonymous. So there's no like ability to stay anonymous. In case of server-client architecture, we don't need to stay online. We can like leave our message or image in the server until the other client will get it. And of course, server provides some additional power. Calculations, he can perform something on your messages or something like that. And of course, the server can perform as a provider between you and the other guy, so you can do some anonymous exchange. So, sometimes you're forgetting to drink water on the presentations, and I think it's very important. Oops, I have a bug. By the way, why do we call an error a bug? We don't think about it, but we always call it a bug, a bug, a bug. Why?
Know the situation with the relays.
Yeah. Okay, great. So actually, there was a woman called Grace Hopper, and she was working on the Mark II computer. It's back then where computers, again, was like this wall. And her team were investigating on the issue when something went wrong, yes? So they were searching for the cause, and they actually found it. They found a moth in the relay, computer relay, and this was like the issue. And this woman takes this bug, tapes it to her journal, and doing a note. First actual case of a bug being found. And like this expression becomes so popular, so like engineers started to use bug as a explanation of the error, right? So, back to our connections. How we are all connected. How it's possible that if I'm sending through the Slack the message, it will be in a second, not in the seconds, in a milliseconds, it will, my colleague from United States will receive it. We are all connected. How? Via servers, we are client to client, P2P, we exchange information. And then even servers talk to each other, because there are also can be clients that are talking with each other and asking for something. So there's a lot of servers. This is actual world map of servers around the world. There's a lot of them. And if they're talking to each other, they're transferring data between each other, they're connected. And via Wi-Fi, like internet, and also cables. The research in 2024 found that around 99% of world traffic relies on underwater cables. This is actual map of the cables around the world. They're connecting under the sea. And this is, I found the photo of how they look like. Here's the question. Why sharks? Why? Any ideas?
They eat the cables.
Yes. Sharks sometimes attack these cables, and this is actually causing interruptions in the data traffic, right? And there's like few reasons why, few ideas. Of course, we cannot ask the shark why, but first idea is the electric fields generated by the cables mimic the signals produced by fish, triggering the shark's hunting instincts. Or maybe they're just curious about this stuff. Be honest, you will also bite it if you will see something like this under the sea. So yeah, that's how our web applications work. Thank you. My name is Maksim Pegov. You can find me on LinkedIn. You can scan, and yeah. Thank you very much for your attention. Thank you. Thank you. Any questions, by the way?
Yes.
Oh, yeah.
You mentioned that UDP is faster than TCP.
Yeah.
Why?
Why? Good question. I think because it sacrifices the reliability that provides FTP. TCP. Right. So this is my opinion. Am I right?
This is shall answer.
You're in the right direction.
It looks like an interview.
So I give you a direction so you can answer for yourself. Yeah, so thank you for the good question. Good question. Yeah.
I think it's because of it uses some control symbols, check funds, and so on. And this UDP doesn't guarantee delivery of the packages.
Yeah. Actually.
It doesn't guarantee the correctness of the delivery.
Yes. For example, if your UDP connection will be lost for some time, you will not. In case of TCP, if you're having some communication via TCP, if, for example, there's some latency, you will get this like packages that were late by the order, so it will go just slower. But in UDP, if you have, for example, some freeze or some problems, you won't get the information that was like transferring in this period of time when you got some freeze. So it's like in the video calls, you are like, if there's some problems with your internet, it's like freezing, and there you're hearing something that is in real time, like continuing. You're not, yeah. So that's how you.
But why sometimes when you have a video call and someone freezes, then you get all of the packets? Because,
for example, Google Meet, it don't use UDP. Oh, UDP, yeah. Because it's going through, basically most of our applications use server-client architecture. Like it have a good connection, fast, strong servers, and it's like going usually through the servers, you know.
it depends.
It depends.
Yeah, not good client server, you can interact somewhere.
Yeah. Do you actually know examples of P2P applications that use P2P connections?
Old games.
Old games. Yeah. Like this connection can be used for some video games, some. Yeah. Actually, the Tor. It's like it's actually this P2P stuff. It's how it's working. Yeah, that's it. Any other questions? I think. What?
Thank you.
Thank you very much. Thank you very much.